Hello everyone, my name is Patrick Flanagan and I'm a current student of SWENG 837, the Software Engineering Masters at Penn State University. Today I'm going to walk you through the design and requirements of a high-frequency trading system. High-frequency trading dominates financial markets by driving significant trading volumes, influencing liquidity, price discovery, and volatility. While this can enhance market efficiency, it also raises concerns about increased volatility, market fragmentation, and regulatory challenges due to risks like market manipulation. These types of applications are advanced software systems that execute large volumes of trades in milliseconds using algorithms to exploit small market inefficiencies. Traders develop these systems for competitive advantage, often co-locating their platforms near stock exchanges to minimize latency and capitalize on market changes. One of the most glaring and successful examples of this type of trading is the Medallion Fund, operated by Renaissance Technologies and funded by Jim Simons. It is one of the most successful hedge funds known for its use of sophisticated quantitative models and high-frequency trading strategies. Academic studies have shown that this type of trading can cause or exacerbate market crashes by rapidly withdrawing liquidity and amplifying price swings during periods of market stress. For example, the 2010 flash crash is often cited as a case where this type of trading plays a significant role in the sudden drastic drop in market prices. A study by Kirilenko et al. In 2011 titled The Flash Crash, The Impact of High-Frequency Trading on the Electronic Market provides detailed insights on how this type of trading can contribute to such market disruptions. Now for the problem statement and requirements for this project. The primary objective of this system is to address the need for high-frequency trading by providing robust platform to train, host, and execute trainable market algorithms for high-frequency trading. The system must support rapid order management, seamless market integration, quick trade execution, and advanced portfolio management. The target users are individual traders, institutional traders, or like for the viewing and compliance activity, the compliance officers themselves. The business goals are to increase trade volume by reducing latency, improve decision making through the use of analytics, and enhancing user satisfaction with reliable performance. Now for the non-functional requirements of this project, the performance. The system must be scalable with millisecond level response times and the ability to handle high volumes of trades. Security aspects for authentication provide a scalable user authentication mechanism, authorization, implement role-based access control, data encryption to ensure data protection, encrypted data both at rest and in transit. For the maintainability aspects, we've implemented database normalization that optimizes its structure for efficiency and scalability, implemented modularization to ensure clear separation of concerns within the system, and non-overlapping functions designed with distinct, non-redundant components. Lastly, we have compliance, which leverages technologies for adherence to financial regulations, high availability to ensure redundancy and failover, reliability, utilize auto-scaling and load balancing for consistent performance. Lastly, usability, optimize the user experience via services tailored to reduce latency, the primary aspect for high-frequency trading. Overall, the use case diagrams I'm going to show you highlights the key actors, traders, market data providers, and clearinghouses who interact with the systems. Traders perform actions like placing orders, viewing market data, and executing trades. The system interfaces with external market data providers to retrieve real-time information. Here's the use case for viewing the market data, going through opening, authenticating, navigation, entering of the information, retrieving it, and viewing the market data. For training a model with market data, once you've navigated to your respective section, you retrieve the market data, train it, receive the confirmation, and you save your model with the respective confirmation. And the other actor is the market data provider. For use case 3, the trader goes through the application, authenticates, navigates to the strategy creation section, inputs parameters, validates it, and saves the trading strategy with the respective confirmation sent to the trader. So for executing trade strategy, going through opening, authenticating, selecting your trade strategy, executing it, settling it through the clearinghouse, and receiving a respective settlement confirmation. For the sequence diagrams, the sequence diagram illustrates the flow of activities in a typical trading scenario. It shows the interactions between a trader and the system, such as logging in, retrieving market data, and placing an order and receiving confirmation of the trade execution. So for the first one, we have view market data, trader executing various methods to open, authenticate, access the account, entering the stock information, retrieving it from the market data provider, and viewing it itself. For the train model with market data, trader navigates through the HFT application, goes to the account portfolio strategy, access to strategy, select training data, and then trains the model, gets its confirmation, saves the model, receives save confirmation. For the create trading strategy, trader goes through, authenticates, and accesses the account portfolio, create the trading strategy, configure it, validate parameters through a decision loop, gets the validated parameters, saves the traded strategy, and receives respective confirmation. For executing trade strategy, the trader navigates through the application, account, its portfolio, and strategy, executes the trade, communicates the trade to the clearinghouse. Trade is validated, get confirmation is then sent through the portfolio back through to the trader. For the activity diagram, further details interactions between the trader, the trading high-frequency trading system, market data provider, and the clearinghouse, highlighting the process of order placement, validation, execution, and settlement in the high-frequency trading applications. So we start the application, place our orders, receive orders, validate orders, the market data provider, then the clearinghouse receives the orders, executes, sends confirmation, trader receives the confirmation that it's in process, then the clearinghouse settles the trade, and the trader receives the settlement confirmation. The domain model for the high-frequency trading application outlines the key entities such as trader, account, portfolio, trade, clearinghouse, strategy, machine learning model, and market data and their relationships. Traders manage accounts and portfolios, develop strategies, and execute trades, which are settled by the clearinghouses. Strategies may be enhanced by machine learning models trained on market data to optimize trading decisions. This model emphasizes structured interactions and dependencies essential for efficient high-frequency trading operations. The class diagram details the key classes in the system, such as trader, order, portfolio, and market data. Each class contains attributes relevant to its role, like trader class with email, name, the order class with order type and status. Relationships between classes, such as the association between trader and their portfolio orders, are also depicted, reflecting the system structure. For the state chart, we're going over the state diagram for a trade life cycle. The state chart diagram explains the state transitions of critical objects, such as an order. An order might transition through states like pending, executed, and canceled, with select specific actions triggered by these transitions, such as notifying the trader and updating the portfolio's value. The component diagram looks different from all the other ones because I did a deep dive into plant UML. So what we're looking at here is a modular structure as the trader navigates through various services to execute and settle their trades. The plant UML diagram was meant to kind of serve as a Terraform for UML modeling, which will be useful in the future when I probably want to automate the creation of these programmatically within like GitLab runners. So for the doozy of the architecture pattern, the system adopts a microservices architecture where each core function, such as order management, is handled by an independent service. This approach allows for independent development, scaling, and deployment of each component, ensuring that the system is both scalable and resilient. The choice of microservices is justified by the need for high availability, flexibility in scaling specific parts of the system, and the ease of maintenance. So for example, we have users, and then we also have a deployer rule, which is can be used by the developers to check their application. The application navigates through Route 53. CloudFront hosts cached data for the big thing here when users want fast access to data. Fast access to data is also enabled through data streams, the Kinesis data streams, where you have a pathway for data analytics, you have a pathway for archival, and pathway to training your models. The development of the application, you have code pipeline, which you have AWS code commit, which has just been recently kind of defunct, but you could substitute GitHub or GitLab in there. Then you have code build, and then ECR for the images, Beanstalk, and code deploy to manage through Elastic Container Service, the Docker containers, application load balancer serving as the go-between between applications, and then respective Aurora, which has structured data, and DynamoDB, unstructured data, with archival for simple storage service. When the user executes on specific actions, Lambda and SES are there to receive confirmation. For the system administration and support, goes to a Bastion host to enable secure communication to access and manage the application. You have various applications for logging and metrics like CloudWatch, and a simple storage service S3 again for archival. X-ray for tracing activities between the applications. Security by region. It's either regional or global, for role-based authorizations, certificate management for encrypting of data, key management service for the key management portion of encryption, guard duty to ensure your application is performing according to a certain set of rules, shield for DDoS protection, secrets manager for the secrets rotation, parameter store for your programmatic parameters, CloudTrail, AWS config, and storage service for archival purposes. So for the design principles, we have GRASP, Solid, Gang of 4, our GOF, microservices, database normalization, and YAGNI. So the GRASP patterns, such as information expert and creator, ensure responsibilities are well distributed across the system. Solid principles ensure that the system is modular, extensible, and easy to maintain, with clear responsibilities assigned to each class. The Gang of 4 patterns, like strategy and observer, are used to handle dynamic training strategies and real-time market updates. Microservices pattern, the system is decomposed into microservices like trader service, order service, market data service, each responsible for specific aspects of the trading platform. Database normalization ensures efficiency, consistency, and integrity of the database, adhering to the first three normal forms, applying the dry principle. Under YAGNI and KISS, they are applied to avoid over-engineering and ensure the system remains simple and focused on the current requirements. So the key takeaways here is that in conclusion, the high-frequency trading system is designed with a comprehensive understanding of the needs of various stakeholders in the trading environment. The architecture is robust, scalable, and adheres to best practices in software design, ensuring it can handle the demands of real-time trading while being flexible enough to evolve as the market needs change. Due to time constraints, more detailed information is available on the full PDF. And lastly, I no longer have to build the boat during the storm. I am used to extreme programming. Now, through this class, I have the ability and the foundational knowledge with backing literature for progressive design and modeling. Other information I have here is my GitHub page, which will be updated with a link for this video that'll be hosted on YouTube, and the project requirements in regards to images, PowerPoint, and the PDF, which will have the detailed information on here. The works cited, of course, is the how I was able to get to the third normal form, having gone to class in a number of years to be able to access that kind of knowledge. I kind of winged it for a bit, then I just wanted to check it online. Flash Crash itself has a LinkedIn poster where it has the culprit of what caused it. The Medallion Fund, a little bit of information on there for institutional investor. The academic paper for that I was referred to by a financial analyst I worked with, a fellow a mathematician that I was a DevOps person for, is available. And then just the overall image I got for the concepts of HFT. Thank you for your time.